Students, yesterday we were discussing about just briefly we have discussed what all the chapters are there. So that is we have discussed briefly the syllabus of the subject machine design. Okay, so today we'll be starting with the first unit, that is introduction to design. Okay, so we'll just discuss introduction to design. Okay, so yesterday we have discussed. So yesterday we have discussed, so that is there are 6 chapters total. Introduction to design, so then design of fasteners, design of shaft and keys, then design of simple machine parts. Okay, then fifth unit is design of springs, then last unit is ergonomics and aesthetic considerations in design. So these all things we have discussed yesterday. So what is the marks weightage, and then so what all it is. Okay, that is theory part and problematic part. So first unit, so that is first unit and last unit consist of theory, where other units, so that is design of fasteners, design of shaft and keys, design of simple machine parts, and design of spring consist of problems. Okay, this consists of around 20 marks. So shaft and keys consist of 20 marks. Then you are having simple machine parts, that is quarter joint and knuckle joint and coupling. So there are three types. Around these three types, among these three types, any two will be given to you. That is, any two will be given. You have to solve one. Okay, and it consists of 25 marks. Okay, problem. And yesterday I told in shaft and keys it is having 15 marks problem and 5 marks theory. Okay, I had just told okay, reverse of that I had told 5 marks problem and 15 marks theory. It is not, so it is having 15 marks problem and 5 marks theory. And in design of springs, so it is having 20 marks. Okay, 20 marks. And last unit, that is for, so that is for 10 marks. So this is for 10 marks and first unit is for 5 marks. So now today in this unit, in this part of a lecture, we will be starting with the first unit, that is introduction to design. So in this unit, what all we are studying is what is machine design we are studying, and types of design we are studying. Then we are studying what is the basic things we are studying for, that is required for studying this whole okay subject. What all prerequisite is there, what all is required, we are studying in this first part of okay first unit of the lecture, which consists of only 5 marks. So it will be asked 5 marks theory will be asked, so we will be studying that. So now we'll directly start with the introduction to design, that is first unit, that is machine design, that is introduction to design. So first, what do you mean by machine design? Okay, machine design is nothing but it is a creation. Okay, it is creation of a new design, or already if any of the machine or anything which is existing is there, already it is there you are improving. So here it is creating new thing, or it is already existing machine or any component is there, you are improving that. So that is defined as machine design. You understood? Machine design is nothing but creation or improvement of existing one, and creating new design or improving a existing one. Okay, so if you just okay, next if you go, it is classification of machine design. If you are designing, there are variety of design. Okay, and there are different types of design. That is, first one is adaptive design, development design, and new design. So we'll just study one by one. So that is adaptive design. So what do you mean by adaptive design is, see, already one machine is there, so there only you are just repairing it. So that is also called as design itself. See, already existing is there, existing design is there, there only you are adapting or you are improving or you are repairing. So that is called as adaptive design. See here, the designer work considered with adoption of existing design. Already design is there, that design you are improving it. The designer makes only minor alteration, small alteration he is making, and he is improving that. So that is called adaptive design. You are adopting a small method or small improvement, so that is called as adaptive design. Okay, so next is development design. See, before studying development design, see, you understood what is adaptive design. You are adopting a small improvement, that is called adaptive design. So in next is new design. New design means there is no particular product or particular machine. So before it is not there, you are developing own. Okay, you are developing a new machine. So that is called as new design. You are developing a new design. Here you are already that machine or some thing is working, there you are improving, it is called adaptive design. So if you are developing own, that is different one, that is new one, then it is called as new design. So what you mean by development design is, it is in between these two. So you are adopting also and you are designing also, you are developing a new research also. So that is in between it. If it is there, then it is called development design. So what you mean by development design? The type of design need considerable, here both are required, scientific training and research is required. That is for developing a new one. See, if already it is there, you should not, you need not apply any mind, or if you need not apply any research or scientific method. Okay, suppose if it is already, if you are okay, if you are designing a new one, you require scientific training and design ability you require. If you are adopting, there you are doing a minor alteration, there you need not have so much of research work or training or design ability. So such type of design where both are involved, scientific training and design ability, to in order to modify the existing designs. Here modifying the existing design, that means you are, see here, scientific training means new design, or design ability means new, whereas modifying or adopting is nothing but adaptive design. If it consists of both adaptive design and new design, then it is called as development design. So adaptive design is nothing but you are adopting, minor alteration you are doing in an existing design, it is called adaptive. Development design is, it includes both a new design and you are adopting a small changes, that you are modifying a small changes or minor alteration. Such design is called development design. Okay, next is new design. New design means by research or technical ability or creating and thinking, by this you are creating a new machine, or you are creating a new machine using research, technical ability and design or creative thinking. Such type of design is called new design. Okay, these are the main three types of okay, and that is the classification of design. Then okay, so then other two types are also there, that is rational design and empirical design. So what do you mean by rational design is, so by in an industry you might have seen, okay, if you are designing a machine and sending it to the industry, their industry, if the stress increases, there stress and strain increases, by seeing that stress and strain you are deciding their dimension. So by seeing their, so by rational method, such type of method is called as rational method. You are designing based on stress and strain, how much stress is there. If 400 megapascal stress is there, below that you have to design. If you design more than 400, what it happens, that machine will fail, or that components of the machine will fail. So by determining the stress in an industry, by determining the stress and strain of a component, and thereby if you are designing the dimension. Okay, if the design here, the design based on the stress and strain in an industry on that component, then such type of design is called rational design. Rational is nothing but by seeing the stress and strain you are designing that. If 400 is there, below that 400 you have to design. Such type of design is called rational design. What do you mean by empirical design? The design based on, so based on the formulas. So if you are using a rational, okay, that is empirical formulas, based on that formula whatever you are using, and then if you are designing, and by practice and past experience method, if you are using such type of design, is called empirical design. So we have studied what is adaptive design. Okay, then we have adaptive means you are adopting the new methods. Then we have studied what is development design, where it includes both new design and adaptive design. Then new design is nothing but creating own, okay, that is based on research and technical ability, then it is called new design. Then rational design is nothing but based on the stress and strain, if you are designing, then it is called a rational design. Then last is empirical design. Empirical is nothing but you are using a empirical formula, then based on that, if you are designing using a past experience and practice, then it is called as an empirical design. These are the different classification of machine design. So we have discussed what is machine design, then classification of machine design. Then we will go for next, the general consideration. See, whenever you are designing any machine or component, so then you require some prerequisites. So that means, so you should know all this to design. For designing purpose, you should know what is load, what is stress, what is strain. Already you have seen all these, you have studied these things in your strength of material. Okay, so here we will briefly discuss what all it is, and then we will move on. Okay, that is, first is load. Okay, suppose if I take a component here. Okay, suppose if I take a component here, and then if I just apply a force here, that is force or load. Okay, so this force, okay, it may be F force, or it is load. Okay, if you are taking this force, so this force is nothing but you are applying a force, the force acting on a body. So this force whatever acting on a body is nothing but it is called as load. Okay, it can be given by F or W. So usually F or W will be given in SI unit Newton. Okay, force is given in Newton, mass is given in, okay, kg, and force or load will be given in Newton. Okay, so then we'll discuss. See, now whenever we are applying, if I just take this example. Okay, if I just take a force W or a load W. Okay, if you are applying, so, and if suppose the area of this thing is A, if suppose area of this thing is A, then whatever the stress is nothing but it is whatever the load acting W divided by whatever the area it is acting. So whatever the area it is acting is called as stress. So what do you mean by stress? Stress is nothing but it is the ratio of load to the area. So whatever the load it is acting to the, what is the area of this thing is called as, it is called as stress. Or so when you apply a load and on this area, what will happen? There is an internal resistance in the material to the applied load. For this load there will be a resistance, it will resist that, it should not have any deformation. So, or it is called as internal resistance to the, in the material to the applied load is called as stress. So you can just remember this, it is the ratio of load to the area is called as stress. Or okay, you can study this also or this also. It is better to study this, the ratio of load to the area, it is the ratio of, it is the ratio of load to the area is nothing but stress. Okay, then we will study, it is given by sigma. And what is the unit of this? See, load is given by Newton. Okay, correct, Newton. Okay, and area is given by what? Meter square. So Newton per meter square. So Newton per meter square is the SI unit of stress. So then we will study what is strain. See, what happens is, see, whenever you are applying a small force, so that is W on this component, so then what will happen? This component, if I just take here, okay, it will just after applying a force, what will happen? It will change its length. So it will be elongated like this. So here it is there, this one. When you apply a force, so it will elongate. This, see, this change in length. See, original length was L. Okay, now the, see, it has changed this length. I'll just take here. In small change in length is called as delta L. Delta L means small change in length. So is nothing but, strain is nothing but change in length, or I can take this as x also. Okay, better I'll take this as x. Okay, x. I'll just take this as x. This change in length is the, no, this is nothing but x. So what you mean by strain is, so it is increase in length, that whatever change in length or increase, how much increase is there, that increase in length to the original length. Original length is what? This is original length. So this is original length. So x divided by L is nothing but strain. So what is the, it is the ratio of change in length or increase in length to the original length. So increase in length to the original length is nothing but strain. So now what it is given by F, okay, it is given by, strain is given by this thing. Okay, now what is the unit? Can you tell what is the unit of strain? See, this increase in length is also given by meter, and original length is also given by meter. So both will cancel, so it does not have any units. So sigma is having unit of Newton per meter square. Okay, and load is having Newton, so that is, load is having Newton, stress is having Newton per meter square, strain will not have any units. So both meter will cancel and you will not have any units. So general consideration, so whenever you are studying a design subject, so you should know all these things, that is what is load, what is stress, and what is strain. Okay, and these all things we have studied. Now, so before moving to this, next is stress strain diagram for mild steel. So what is stress strain diagram for mild steel? Before discussing this, we will just discuss few things, that is which is required for you. So if I just take a component, okay, if suppose if the forces are both are like this, then it is called as tensile. Okay, it is called as tensile. Okay, if suppose if I take a component, if the forces are like this, okay, then it is called compressive. Compression. Why it is called compressive? See, whenever if you are applying a load like this, so what will happen? It will decrease its size. So it will decrease its size. Where when you are applying a forces like this, what will happen? It will increase its size. Okay, so it will come here, so it will elongate here, it will compress. So it is called compressive stress, and this is called tensile stress. If suppose if I take one more example, so that is called, so if suppose the component is like this, and if I am applying a force on this area, if suppose if I am applying a force on this area, so if the force is like this, or if I apply a force here, okay, if I apply a force on this area, okay, if I apply, then such type of stress is called shear stress. Okay, shear stress. So you should know the tensile load, it is called tensile load, and stress developed is called as tensile stress. Compressive load and stress developed is called as compressive stress, and shear load, this is called shear load, and the stress developed due to such type of load is called as shear stress. Okay, these are the basic things, because whenever you are studying in your problems, okay, it will be given the tensile stress will be, okay, how much, 400 Newton per meter square it will be given. So tensile means you should understand what do you mean by tensile, what do you mean by compressive, you should know, and what do you mean by shear stress, that is also you should know. So this is the basic things whatever we have studied. Okay, so and what is the unit of stress? Stress is given by, what is the unit of stress? If whether it is tensile, okay, whether it is tensile stress or compressive stress or shear stress, what is the unit of this? And just we have discussed, it is nothing but Newton per meter square. Okay, it is nothing but Newton per meter square, or Newton per meter square can also be called as Pascal. Pascal, okay, Pascals, or just it is given by PA. PA is nothing but Pascals. Okay, so in your problem statements it will be given as stress of 50 megapascal or 50 Pascal. 50 Pascal is nothing but Newton per meter square. Okay, so tensile stress of 500 Pascal is nothing but 500 Newton per meter square. Newton per meter square is nothing but it is Pascal. So these all things we have studied here. So we have just discussed what is, okay, we have just discussed what is machine design and different classification of machine design. So that is adaptive design, development design, new design, rational design, and empirical design we have discussed. Then we have discussed general consideration like what is load, what is stress, and stress is, load is given by Newton. Okay, load is given by Newton and stress is given by Newton per meter square. And what is stress we have studied, and then strain we have studied. What do you mean by strain? Strain is nothing but it is change in length or increase in length to the original length is nothing but it is strain. Then we have studied so different types of loads. So we have studied different types of load. If it is both are in this direction on a component, tensile stress. If both are in this direction, then it is called compressive stress. And if suppose if it is on the area, then it is called as shear stress. See, understanding these basic things is very important, because whenever you go for the study of next chapters and all the problems, it will be given tensile stress, compressive stress, shear stress. You should know that what do you mean by tensile, what do you mean by compressive, what do you mean by shear stress. So briefly we have discussed what all things. So in this whole first chapter we'll just go on discussing like this, whatever the basic things are there, then we'll okay, go for the next chapter. So first unit is very important, though the marks weightage is less, but you should understand all these things, basic things you should know. Okay, so then in the next coming lecture we'll just discuss what is stress strain diagram for mild steel, and different points we'll just study: proportional limit, elastic limit, yield limit, ultimate limit, and fracture point. So this is very important. So if you just take every year, it will be asked, this thing will be asked for 5 marks. So it is very important. So in this first chapter, whole chapter, if you just take this question, the probability of asking this question is more. So we'll just briefly will study this elaborately. We'll just study this stress strain diagram for mild steel in the next coming lecture. Okay, so that's it for this lecture. Okay, thank you.